let us look at the last lesson for functions where we're talking about combining transformations. Now, just a quick recap. Vertical transformations are all transformations in the y direction, meaning up or down, right? So you can have translation up or down. You can have reflection in the x-axis, which brings up to down and down to up. And we can have the stretch in the y direction, right? Which makes it longer, right? And then we have other horizontal transformations, which are translation in the x direction, reflection in the x direction, meaning making your mirror as y, and finally stretch in the x direction, which means making it wider, right? And now the question comes, does the order matter when you are combining transformations? Okay, meaning does it matter what we do first? If we do the stretch first or if we do the translation first, does it matter? And we're going to take a look at these three examples, okay, in specific over the next 3 slides. So let's go to the next slide and check out the first one. So in the first one, y equals to 2f bracket x minus 3. And what this is doing, there are two ways to go about this. Is you first start off by multiplying by 2, meaning you stretch in y-axis by scale factor of 2, and you end up getting 2f of x. Okay. Then after that, what do you want to do? We want to translate to the right by 3 units because it's minus 3. Remember, we had done it already, translation. So translation, we usually use a vector, so 3 units to the right and 0 units up or down, right? And so we end up getting 2f x minus 3. We get something like this, right? And we end up with what we had initially. Now, what if we switch these around? What if we start off with the translation? Translation 3, 0, where we go? Y equals to f x minus 3. Then we would stretch in the y-axis by scale factor of 2, and we would multiply the whole thing by 2. So we have y equals to 2f x minus 3. And here, there was no difference in the final answer if we just switch the order around. And if you notice, why does that happen is because the first one is a vertical transformation and the second one is a horizontal transformation. So they are independent of each other, right? Because they're independent, it doesn't matter what you do first or what you do second. Okay. Now let's look at the next example. We're looking at 2f of x plus 3. In this, you can either start off with the translation upwards, okay, or you can start off with the stretch by scale factor 2. So we're going to do both. Let's start off with the stretch first. So stretch, just like the previous one, y-axis, scale factor of 2. We end up getting from f of x, we get 2f of x. Then we would translation. Your vector is going to be 0 in the x because x does not change, and y goes up by 3. And so we end up getting 2f of x plus 3, which was what we wanted initially. Now, what if we switch these around? Now, remember, both of these are vertical transformations, right? And so they do depend on each other. Let's see what happens. Let us start off with the translation. 0, we end up getting y equals to f of x plus 3. And then we want to stretch by scale factor 2 in the y direction, right? And here, what does this do? Is it multiplies the entire equation by 2. And so what happens here is y equals to 2 f of x plus 3, right? Because now this whole thing is your equation. And this just makes y into 2y, which means it changes this entire thing into 2 times that entire thing, which gives us 2f of x, which is the same thing as the first one. But then we have plus 6 instead. So if you can see here, there is a problem. Why? Because we started off with the translation and it gave us a different answer than what we wanted. So the order here depends because they are both vertical transformations. Okay, let's look at one more example. Now let us see what happens if they are both horizontal, right? So again, we're going to start off with stretch. Remember, this is in the x-axis, x direction. with scale factor of a half, right? Remember, we inverse the thing that's multiplied, and we get y equals to f of 2x. Okay, then you would translation, and this moving to the right, so the 3, 0, and that would end up giving us y equals to f2. Remember, x turns into x minus 3. So here what's happening? 2x has become x minus 3, which now tells us that it becomes f of 2x minus 6, right? Which is not what we wanted initially. But let's look at the other way. What if we switch these around? And we start off with translation 3, 0, which gives us y equals to f x minus 3, right? Then we would stretch scale factor of a half in the x-axis. And we end up getting y equals to f. Remember, here what's happening is x is becoming 2x. And so f 2x minus 3, which was exactly what we wanted initially. The main point is that these two are different because we changed the orders. Why does order matter in this case? Because both are horizontal transformations, right? But if you noticed, the previous one that we saw, the correct way of doing it was to apply the stretch and then apply the translation. While the second one, which is horizontally, we had to apply the translation first and then apply the stretch. Now, let me just explain generally, okay? When you have y equals to a f of x plus b, meaning you are having a translation in the x direction and you're having a stretch in the y direction, yeah? It doesn't matter, the order doesn't matter, yeah? Because they are in different axes, meaning they are independent of each other, as I said. Okay, so if you see both ways, if you start off with the stretch and then the translation, or you start with the translation, then the stretch, you will end up with the same thing. If you look at the combined transformations in the same axis, which is the second example here, we are currently looking at a stretch in the y direction and a translation in the y direction as well. In this case, the order does matter, right? And if you want to start off with the translation first, we have to make some changes, which is you would use the translation units divide by the scale factor that you used. And the reason why, because at the end, you want to use the scale factor to stretch it. And if you multiply this by the scale factor again, they're just going to cancel out and you will get the original translation units that you want, which is what happened here, right? You translated by b over a because a was your scale factor unit. And then you would multiply by that same a at the end. And so these would cancel out, right? And obviously the a goes to f of x as well. And this is how you can switch them around. But the better way is you would start off with the stretch, then you go to your translation because of BODMAS. You always multiply before you add. In this example, however, again, we are going back to our x transformations are inversed. Yes? And we are using that here as well. Now, if you wanted to have it the normal way, you would start off with the translation and then you would stretch it, as we know, and we would inverse the scale factor, right? And you would get what you wanted initially. This is, by the way, a stretch in the x direction and a translation in the x direction as well. While if you want to do it the other way around, you would start off by applying your stretch. Then again, you would go with your translation unit, obviously negative in this case because it's in the x direction, over your 1 over scale factor, which you are using to multiply afterwards, right? I mean, which you used to multiply before that. And what this does is it would cancel at the end, and then you remain with your translation unit as you did with the previous. But because here what's happening is that the second term is adding it in brackets, meaning you have your, for example, you have your scale factor and you get f of ax. And then what happens here is that you put a bracket in for x because x is changing. And this becomes x minus whatever you want, b over a in this case, right? And or plus b over a for that matter. This is what it would look like. And as you can see, what we do first is we would multiply this inside and obviously with the x as well, and we would end up with this as we wanted. So in order to do transformations in horizontally, the way we would do it is reverse BODMAS, right? As you know, x transformations are inversed as well. You can remember it in the way that even your what to do first will also be reversed, as I showed you right here, because that second term is added in brackets at the end, right? So your translation will be added in brackets. That means it would still be multiplied by the scale factor after. It wouldn't be multiplied by the scale factor before. Now, let's do some examples. The first one being, given that y equals f of x, find in terms of f of x the equations for the following transformations. So translation by 3 and -1, which means x is becoming x minus 3 in terms of f of x, and y is becoming y minus 1. And therefore, we would take our f, our x has become x minus 3, and we subtract 1 to the entire y. And we end up with that. Second one, a stretch parallel to the x-axis of factor 1 over 3, a stretch parallel to the y-axis of factor 2. And because these are in different axes, this is x and this is y, it doesn't matter what we apply first. We can just do it straight away. And so for this one, we know that x is becoming 3x. And this one, we know that y is becoming 2y. This is inverse because in the x direction. And so we'd end up with 2f of 3x. Okay? Because this one starts off with making it f of 3x. Then this one, you multiply the whole thing by 2, which should end up with this. Then next, a stretch parallel to the x-axis of factor a half, and then a translation by 4. Now here both are in the x direction, so we have to do it step by step. This one does what? X becomes 2x, which means f of x is becoming f of 2x. So we are here right now. Then we are applying to translation 4 units to the right, which just means x is becoming x minus 4. And if you are confused as to why this happens, go back and watch the lecture when I talk about translations and reflections. Okay? And then what happens is that x is becoming x minus 4, so we end up with f of 2. X has now become x minus 4, which then makes it f of 2x minus 8. And then finally, translation of 4 followed by a stretch. So firstly, x is becoming x minus 4, which means f of x has become f of x minus 4. Then what happens is your x is becoming 2x. So f of x minus 4 has become f of 2x minus 4. And this is what you get. So you see these are different because as we did the examples previously and the explanation for that. Next, describing combined transformations. Yeah. Now we need to describe what they are. Before we got the description, then we had to apply it. Now we have their application and we have to describe it now. So here what's happening is that your x has become 2x and your entire f of 2x has added 4 to it at the end. So basically y is becoming y plus 4. And these two combined have done what? So firstly, there is stretch parallel to x-axis, scale factor of a half. And then there is translation and your vector is 0, 4. And remember, we can switch these around. Why? Because they are in opposite axes. So they are independent of each other. Next, there is, firstly, the f of x has now become negative f of x, which means the y has become negative y. And then after that, what's happening is that you now have negative f of x. And what we're doing is we are adding 2 to it. Yeah? So our y is becoming y plus 2. And here it's very important to remember, as we said, start off as BODMAS goes. So we want to multiply first. Yeah, you're multiplying by -1 first, and then we want to apply the translation. So this multiplication is not a stretch multiplication, it's a reflection multiplication. And so we are first reflecting in x-axis, and then we are translating by 0, 2 units, right? And here you cannot change the order because they are both in the same y-axis. If you want to change the order, then you'll have to change the translation value. As we said, with our new translation value, let's just call it translation new, would equal to the translation unit over the scale factor, which in this case is -1. So it would just make the 2 into a -2. Okay, next. We have y equals to 4 minus x. So firstly, what's happening here is that x has become -x, because remember, initially we have f of x. How do we get to this? Firstly, x has become -x. You always look at the variable first. X has become -x. And then what happens is, we now have f of -x. Then what we did is, we want to make it f of -x plus 4. Remember, our changes to x are going to be in this format. F of -x plus a. Because the x is going to be changing to x plus a. And so we want to factor out the negative right here. We end up getting f of -x minus 4. Right? And here what's happening is that if we apply the reflection first, so x is becoming -x, which is a reflection in the y-axis, then we will have to then translate it to the right, meaning our x wants to become x minus 4, which means translation 4, 0. The other option is what? Is we add the 4 term first, then we can reflect it. So firstly, we do x becomes x plus 4, which makes it f of x plus 4. Then we make x becoming -x, which just makes it f of -x plus 4, which makes us go into the same thing as we had previously. Okay, so in this case, we would first translate to the left by 4 units, because we are making x into x plus 4, -4 and 0. And then we would again reflection in the y-axis. So here order matters. Reverse BODMAS, meaning we do the translation first and then we do the reflection if we want to keep the terms as they are. Okay? That's example 2. Example 3. G of x is obtained by applying the following sequence of transformations to f of x. Find an expression of g of x given that f of x is this, and these two transformations have been applied. So translation by 2, 0, meaning x is becoming x minus 2, which means it's moving to the right by 2 units. And then a stretch parallel to the y-axis of factor 4, meaning y is becoming 4y. Are these transformations in the same axis? This is x, this is y. No. Okay. And they are in the different axes. And so are we going to use BODMAS or reverse BODMAS? It doesn't matter. Order doesn't matter in this case because the transformations are in different axes. And so we can just apply this straight away, where x is becoming x minus 2 first. So x minus 2 squared minus 2x minus 2 minus 2 at the end. Then what we would do is multiply that entire thing by 4. And so we end up getting 4 of x minus 2 squared minus 2x minus 2 minus 2. Then we can open out the brackets and all that. We end up getting 4 of x minus 2 squared minus 8 of x minus 2 minus 8. And that's going to be our g of x. Next, we want to sketch combined transformations. How do we do that? So the diagram right here is y equals to f of x, and we want to do this right here. We want to stretch scale factor of 2, and then we want to translation y by 3 units downwards. That means firstly y is becoming 2y, and then secondly you have y becoming y minus 3. So scale factor of 2, y-axis stretch, and then we end up with a translation with vector 0, -3. Okay, are these transformations the same axis? Yes, and this is the y-axis, which means we're going to use BODMAS instead of reverse BODMAS. Okay, so firstly we apply the stretch, which means every y value is becoming 2y. So firstly, here 3 will become 6, here 3 will become 6, here -1 will become -2, here 1 will become 2, and here 1 will become 2. And currently we have this. I'm going to draw it in dotted line so that, okay, we have something like this right now. Then what we're doing is we are moving it down 3 units. So we are going to move this 3 units down, 3 units down, and then this also moves 3 units down, and everything is basically moving 3 units down. And we end up with something like this. So let me just change the color really quickly. And I put this. So red, and then this goes down up to here now, and then to here, and then finishes right here. So these are the two transformations that have been applied. And here we have to do BODMAS because it was in the same axis and the axis was the y-axis. Okay. Okay, the final example, we're describing the combined transformation, and this seems like something in the x-axis. Okay. So find two different ways of describing the combination of transformations. Now here what's happening is that firstly, we can see it's becoming thinner. That means there is some stretch in the x-axis, okay? And then there is also a translation. Now, how do we know it's a translation? Is because we can take any y value. Let's just take y equals to 0, right? And we check the original x, and the x here is going to be 0. Then what we see at the end is that in the new transformed, the x has now become 2. And therefore, that means there has been a translation as well, right? So let's just say firstly, the stretch happened, right? If the stretch happened first, what would occur is that your f of x, which is my x squared in this case, will become f of 2x. And the reason we know it's 2x is because if we see the thickness of it, the thickness at y equals 4 is 4 boxes, while g of x is 2 boxes, which means we know the scale factor here is a half. And if the scale factor is a half, we are making x into 2x because we inverse that operation. So f is becoming 2x and x squared becomes 2x squared. Then once that happens, we would currently have something that's looking like this. Okay. And we want to change it into this right here. So we want to move it 2 units to the right, and we would want our x to become x minus 2, right? And therefore what would happen here now is that our 2x squared, or our f of 2x, both of them, our f of 2x will now become f of 2 of x minus 2, or we can say our 2x squared will become 2 of x minus 2 squared. And so we end up with 2x minus 4 squared. So we want to end up with this at the end, according to our calculations right here. And to get to this, we can go two different ways. We could start off with the x. We could start off with the translation, then go to the scale factor. Or we could start off with the scale factor, then go to the translation. And remember, if we want to do transformations in the x-axis, we would need to do reverse BODMAS, which means if you want to keep it the exact way, we would start off with the translation, then we go into the scale factor and the stretch. So if we want to get this, we can start off with x becoming x minus 4, which means translation in the x-axis by 4, 0. Then we can go into my x becoming my 2x, which is just stretch x-axis, scale factor a half. Or we can start off with the scale factor, meaning scale factor equals a half, then what we want to do is we would change the translation unit. So our translation will now become 4 over, as we said, 1 over SF, which is just 1 over 2, which is just 2. So 4 divided by 2, which is going to be 2. So we can change our translation 40 to translation 20. Okay, so there are two options. And the first option, f of x becoming x minus 4, which just means that my x squared will now become x minus 4 squared first. And then my x is becoming 2x, so it becomes 2x minus 4 squared. So we have gotten what we originally wanted. And the second way, we start off with the scale factor, meaning my x squared is becoming 2x squared. Then I am translating 2 to the right, which means my x is becoming x minus 2. And so 2x minus 2 squared, which ends up giving us 2x minus 4 squared as well. And we end up with the same term for both. So this is how you would do it in the x direction given the graph, right? And that is it. Go through this from the notes down below and give yourself a recap of all of this. I'll see you in the next topic.